we're going to learn how to write equations in slope-intercept form. Remember that slope-intercept form is y equals mx plus b, where m is the slope of the line and b is the y-intercept. Remember that slope, besides being notarized by m, another way to find it is by doing rise over run. So that's going to be y2 minus y1 over x2 minus x1. It's also, when you say it out loud, it's the vertical change over the horizontal change. So it's how much the line goes up or down for every unit the line goes from the left to the right. Also remember that the y-intercept is where the graph crosses the y-axis. This is when x equals 0. So remember that slope-intercept form is any line in the form y equals mx plus b. How are we going to go about writing these equations? Well, it depends on where you start. You could start with a graph. In this case, you're looking for the slope and you're looking for the y-intercept. Once you have both of those things, you can write the equation in slope-intercept form. First, the y-intercept is actually already labeled. The point where it crosses the x-axis is 0, negative 4. So in this case, the b value is going to be negative 4. The y value, so b is equal to negative 4. We figure out the slope by looking at 2 points. And in this case, we have 2 exact points, 2, 0, and 0, negative 4. So m is going to be equal to, remember, y2 minus y1. So in this case, man, I'm having a little trouble with the pen today. y2 minus y1 over x2 minus x1. So we'll call this one y2, so negative 4 minus 0 over 0, that's x2, minus 2. So that's going to be negative 4 over negative 2. Negative over negative is a positive. 4 over 2 is 2, so it's going to be 2. So our slope, in this case, is 2. Once you have m and b, you can write the equation in slope-intercept form because all you need is m and b. So if it's mx plus b, you know y is going to be 2x minus 4. So you could start with the graph. That's one way or one place to start when writing the equation in slope-intercept form. Another place to start would be a word problem like this. Write a linear equation to approximate the cost of collect telephone calls. It's kind of old, huh? You don't really make collect calls anymore. Use the information shown on the telephone bill to create your model. So let's look at one line of this bill. On January 7th, the time starts at 8:57, tells the area number, but it's not really important to what you're looking at. The thing that's really important to notice is that the first minute is 3:44, and it costs 24 cents for every additional minute. So 24 cents for every additional minute comes out to be 440 because it's going to be 4 times this plus this first minute. So the first minute is 3:44, and every minute beyond that is 24 cents. That's how they got the amount. So our question is write a linear equation to approximate the cost of the collect call. So just remember that the first minute costs 3:44, and then each additional minute costs 24 cents. Remember how you need to attack these problems. You're going to write a verbal model first. The way the verbal model works is you need to write it as total cost is the cost of the first minute plus the rate per additional minute times the number of additional minutes. This is going to be the number of minutes past 1 minute. So then you need to label your variables. So let's call total cost T. The cost for the first minute we already know is $3.44. The rate per additional minute is 0, 2, 4. And the number of additional minutes, let's just call T, or lowercase t. I know it's bad, it might seem a little bad to have uppercase t and lowercase t, but we could say this is total instead. Total cost, keep it clear. So now we have this nice algebraic model. So our total cost will equal 344 plus 0.24 times t. The question goes on to ask how much would a 9-minute collect call cost? So remember that t, the lowercase t right here, is the additional minutes past the first minute. Additional minutes. Additional minutes, it's important. So 9-minute collect call, in this case, how many additional minutes are there past 1 minute? It's going to be t equals 8. So the total cost of an 8-minute call, so the formula evaluated when lowercase t is equal to 8 is going to be 344 plus 0.24 times 8. You can break out your calculator to figure this out and find out that the total cost of a 9-minute call is going to be $5.36. So to recap, remember that slope-intercept form is when the line is in the form y equals mx plus b, where m is the slope and y is the y-intercept, which is where the graph crosses the y-axis, which is when x equals 0. You could start with a graph of an equation, in which case you need to know the y-intercept, in this case it was given, and then find the slope by measuring y2 minus y1 between 2 points and putting it over x2 minus x1. And then last, you need to come up with the equation of a linear function given a table of values or a word problem. And you have to remember that you need a verbal model and labels. And in this case, it's important to point out that our y-intercept is 3.44 right here. And our slope is 0.24. So this is our slope and this was our y-intercept. When time was 0, when little t was 0, we would cross the y-axis, total cost at 344. I hope you found this video useful.